Hello everyone, and welcome to Take 1 of my AP Physics 2 project on wind turbines. So, Part 1. Name of my technology. It is wind turbines. Part 2. Operating principles. So, how do wind turbines actually work? Well, it's not that complicated based on what we've learned so far. We all know that wind turbines work because of the wind. But why does that create electricity? Electricity needs a current, right? So how does wind make a current? Well, what we do know is that inside of wind turbines, there are magnets. And the magnets are connected to the rotating shaft of the, whatever these things are called, fans, whatever. And it's connected like this. So zoomed in, you could see that down here. Connected to the wind turbine is a rotating magnet. But how does this create a voltage or a current? Well, it creates a current because of a changing magnetic field, which creates a change in flux. The area is also changing, but we're going to focus on the changing field. So let's say initially the shaft is lined up like this. You got a magnetic field line going down through this coil of wire. Now, that doesn't do anything. It's just like that. It's not moving at all. But if we do move it, let's say wind pushes the fans and turns it like this. Now we got field lines going in the opposite direction. Of course, there's field lines over here too, but they don't really matter that much. So, you got your coil of wire. Well, why does this create a voltage? It's just another magnetic field line. Well, yes and no. It's different because you've had a change in flux over time. And it creates a field because, well, there has to be a field to offset this magnetic field. And why? Well, basically the wire wants there to be no field here because, or no, it wants it to be like the field that it was before. So it's going to try and offset this field so it looks more like this one before. So how does it do that? Well, it creates a current. And that we know that because currents create magnetic fields. And so the main question we have is which direction is the current going to go to make a field that goes down? So this is what we want. Well, you just look at your right hand rule. The field's going up, we want it to go down. So if you hold your hand out in front, and that's your thumb, and line it up with the coils, which are sort of going like this, and then it connects to the voltmeter over here, you see that if you were to curl your fingers up here, as if you're holding it, so if you would curl your fingers up here, and your finger was going like this, you'd see that the field will curl in and then go down in the center. So, go down in the center, and that would offset our field pretty well. And if you go in the opposite way, then it would just add on to this new field that it doesn't like. So it would be going down, and that would create, so the current is going this way. So the current flow is going to the right now. And there's a voltmeter here. And now that we've got a current, we can just hook up some external wire, maybe add a little light bulb here, and there we have it. There we have our power. So the next question is, how is this useful in life? Well, it's useful because we can use it to make clean energy because we have a permanent magnet that we just connect to the rotating wind turbine, and we have energy. And it's pretty great. You don't have to burn things, you don't have to use fossil fuels, it's just the wind, and the wind isn't stopping anytime soon as far as I know. So that's the application to real life. And if you have any questions, feel free to let me know. Cool Sarah KRY. AP Physics 2.